Hello friends, I'm solving a problem on CAM. This is kinematics of machines subject. So the definition of the problem is draw the CAM profile for the following conditions. The conditions will be given along with the problem. So an inline knife edge follower lifts 50 mm. See, the follower here used is knife edge. Okay, so the lift is given as 50 mm. Its base circle radius is 50 mm. During outward stroke of the follower, it follows simple harmonic motion for 60-degree rotation. Outward stroke means lifting, that is up. The follower raises up. Okay. Next, the remaining 45-degree will be dwell. Dwell means there will not be any work done. Okay, so idle period, dwell hour means or dwell period, that is 45-degree till it starts a return stroke. That means the cam is lifted at an angle of 60-degree to 50 millimeters given. So 50 millimeter given for the 60-degree, it will remains upside and during the rotation of 60-degree it will go up and remains in its upper position for 45-degree of rotation of the cam. Okay, here it is given, that is dwell period, and after 45-degree of rotation is completed, then it slows down or retards from this position. It comes to normal position, that is 50 millimeter down. Here earlier 50 mm up, now 50 mm down, that is return stroke, 90-degree of its rotation. And after 90-degree of rotation, again remaining hour, totally 360-degree, total 360-degree. Out of that 60-degree outward stroke, 45-degree dwell, and 90 degrees return stroke. After adding up, how much? 360 degree, 60 degree, 45, 90. So 1 second. So totally 165-degree it will remain dwell once again. Okay, after return stroke. So next we have to determine maximum velocity and acceleration during outward and return stroke, return or inward stroke, if the cam rotates at 1000 rpm. And here the direction of rotation of the cam is given clockwise. Okay, whenever you find problem of this kind, don't just rush to solve this, just read full condition and then start to solve. Okay, so initially we will calculate the angular velocity, maximum velocity and angular velocity. Okay, first, so theta outward stroke is given 60-degree, return stroke 90-degree, and lift 50 mm. So angular velocity omega is equal to 2 pi n by 60, and it is, the unit is radian per second. Next, maximum velocity of follower during outward stroke. So v naught max means outer velocity max is equal to pi omega into s divided by 2 theta naught. Okay, so here we have to substitute in terms of radians, so we have to convert degree into radians. So convert, that is pi radian is always 180-degree, we know that. So for 60-degree, 60 into pi by 180 radians. Okay, substitute here, you'll get v naught max. And similarly for return stroke, same equation, here theta r, earlier it was theta 0, here theta r return. Okay, same equation also here, 90-degree of return stroke, that is converted into radians. And here acceleration pi square omega square into s divided by 2 theta naught square. Here it will be square, here it is normal, no square here, we have to square here. And similarly for return stroke as well. And next, this is displacement diagram. So the lift is given as 50 mm, it's given in the problem, so it is 50 mm. So make sure that this is you can take any scale. So here I have taken 5 centimeter from here to here, 5 centimeter, and this is 180 degree total semicircle, and here I have divided into 6 parts, so each will be 30 degree. Okay, so similarly here I have divided that angles: outward stroke, dwell, inward stroke, and the remaining period of dwell. Okay, so I have taken it as a scale. So this is 0 to 6 each, 1 centimeter. So you can take lesser than this, you can make it more smaller divisions, so that you can get fine lines here, so that smooth curve will be available if you take much number of these things. So I have taken 6. Well, see, after this one 45 degree dwell, so I have taken 4.5 from 6 to 7. Next 7 to this point, 1 2 3 4 5 6. So again this is 90 degree, that's what I have taken it as 9.5 centimeters. Okay, so after that take draw horizontal line from this point to this end, horizontal, similarly to all other points. Okay, after that you'll get points here, this line and vertical line, every time you will get point, this all these points. So you have to join all these points and you have to draw a smooth curve. Okay, so from here it will be dark because it's a dwell, here again to till this point. And after that they are given the base circle radius as 50 mm, draw 50 mm base circle, and after that an axis line, 90 degree axis line, this one. And okay, it is the cam is rotating in clockwise direction, it is given in the question. So clockwise, when the cam is rotating in the clockwise direction, you have to draw the profile in counterclockwise direction, counterclockwise or anti-clockwise direction, you have to draw the profile. And offset is not given, that means the cam follower center and this cam center is same. Okay, if offset is given, follower center changes here for clockwise rotation. For counterclockwise rotation of the cam, the follower comes this side, whatever the millimeters or centimeter they give. If it cam is, now I'll tell, this is rotating in, the cam is rotating in clockwise direction, so we have to draw the profile in counterclockwise direction. At that time, if the lift is given, the lift will come this side. Okay, and if the cam is rotating counterclockwise, that is this way, and profile must be drawn clockwise, at that time this will come here, this follower shifts here if offset is given. If offset is not given, it will remain here itself, and cam center is this one. Next, marking the point. So 60 degree, first mark 60 degree here, from here to here it is 60 degree, and split 60 degree divided by 6 part, because you have taken 6 parts here, you have to divide this 60 degree into 6 parts. So I have divided into 6 parts. So next, after that, draw smooth line or light line. Next, take the measurement from 1 to A, take the measurement and mark it here, 1 to A. Next, 2 to B, here 2 to B, 3 to C, 3C, 4D, and 5E, 6F. Similarly, all you have to mark, you have to measure from here to here. Okay, same distance what you get here, you have to replace it here. Okay, same. Next, 45 degree from here to here, 45 degree dwell. Okay, there is no marking. Next, after this 90 degree, again return stroke. You have to split 90 degree into 6 equal parts. Okay, so from here same, whenever you measure this one, this measurement and this measurement in terms of length will be same. Okay, so this 7 to G, 8H, 9I, 10J, 11K, 12L and 0 again here. Okay, so similarly you have to mark it here, and later you join all the points with the light line, and later on you can make it as thick line. Okay, so this is regarding the cam. And remember, if the direction, I told you, if the direction of cam rotates in clockwise, then profile must be drawn in counterclockwise direction. Please remember that one.